Hey everybody, welcome to my channel. Today we will be learning about another new topic for today, that is total internal reflection. Now this has to be related with the refraction that was a video that I made some days back. So in that refraction I explained what is a refraction. That is, if there is a light and it's going from one medium to the other, then it is bending. And I also told you how it bends. If it's going from a optically denser to optically denser to that medium, or vice versa, then the opposite would happen. And all of that you will get on that video. All of reflection you will get on that video. But today we'll be going a little further from refraction. That is, we'll be starting with total internal reflection. So here is a topic. Let's go deeper in this topic and let's learn. So what is this total internal reflection? So let's start. So look into this total internal reflection. We have to know, we have to look at a scenario, okay, where there is a refraction happening. So suppose here I'm drawing a border line, okay. This is a border line that we show. So here on this part, the upper part, there is one medium. On here part, this part, there is another medium, okay. Suppose here it is glass. So this is glass and here is another medium, so it's going divided, and here it is air. So here we have two mediums. The air is one medium and another medium is the glass, okay. So the glass is what we tell when we're talking about light. We tell it is optically denser, and this air which we see is optically rarer medium. So we have two mediums in here. So now here we will draw a light. So here suppose there is a ray of light that is going. So what do we call this? This is the incident ray. And we draw an imaginary line, that is the normal. So whenever we draw imaginary line, we draw it by dots that we can represent by like this. So this is the normal line, this is the incident ray, and there will be a refracted ray. I hope you got it. So when there is a change in medium, when the light is traveling from one medium to the another, the light always gets bended. Now so there is a rule for that, though. So where it will get bent. So scientists and physicists have understood this concept and told that when it will be moving from glass to air, so as you can see, the angle made by the incident and the normal, this is the angle, the reflected should always be greater. So the reflected should be here almost. So as you can see here, the refracted, sorry, I told the wrong word, refracted angle, this angle, refracted angle will make a more angle, degree will be more than this, okay. This will make a shorter angle when it's moving from a optically denser to optically rarer, then it would go outward, means the angle of the refracted will be more. Now if it's vice versa, if it is from air to glass, which is air is optically rarer to optically denser, when it's traveling to optically denser, then I'm telling you to imagine, okay, then the angle made by the refracted will be less. So whenever we are moving from an optically denser to optically rarer, it will go away, and when we are moving optically rarer to optically denser, it will move towards the normal. And as you can see, this is what is it. So this is what refraction is, and if you want to know more, then you can watch my video. I will give in the description below about refraction, that I've explained the concept very well. Now let's go to the total internal reflection. So now what we will do, here it is an angle of incident ray. Now I will increase the incident ray, means increase the angle of incident ray. So what I will do, I will move it this side. So as you can see here, I have moved the incident ray towards this side, and it will keep on moving. And I can make the incident ray move till here also. It can make any angle with the normal. So suppose now I've made it till here. So now if here, this is here, so this angle is more now. So I have to increase this angle too. I will do that. So it will almost look like this. I'm just telling an example, okay? So this is the incident ray, this is the refracted ray, and you can almost see that it's way too far from the normal. It's making a big angle. If you can see, it's making a really big angle. The line, the refracted ray is here. So it's making a big angle. Now, before learning the concept of total internal reflection, we have to learn that what is a critical angle. So critical angle is a famous case or a famous phenomena that is when the angle of this is a famous phenomena. What is the phenomena? In this case, the angle made by the refracted ray, this is division line, is almost perpendicular to the normal. Almost, it is perpendicular. So the refracted ray is here on the border. It is on the border of the refracted ray, and it's making a 90 degree. The refracted ray is making a 90 degree. So this is a special case. This critical angle is a special case. It is the angle of incidence. So the critical angle is an angle where this angle of incidence will attain an angle. It will attain an angle when the refracted ray angle will be 90 degree. So the incident ray is kept at an angle. Critical angle is like that. The incident ray is kept at an angle where the refracted ray angle will be 90 degree to the normal. So it is a special case. So critical angle is the angle of incidence. Okay. When the angle of refracted ray is 90 degree. It is critical angle is the angle of incidence when the angle of the refracted ray is 90 degree. So it is called a critical angle. This incident ray is called the angle which is made by the incident ray is called a critical angle when it makes a 90 degree. The refracted ray makes a 90 degree with the normal. And in this case that I've showed you, it makes. So I have to move this a little further because we know if we move it more further, then it would go that side. Okay. So this is when it gets a critical angle. Now what happens if we move it more further, more than the critical angle? Then what will happen? So think about it. It can't go that side. It will come this side, down. So now in critical angle, the angle is 90 degree. But if I move it more further, more than the critical angle, more further, suppose like here, the incident ray is here. Okay. Then what will be the refracted ray? Where will be the refracted ray? Where will be refracted? It can't go there on the upside. So what will happen is the refracted ray will reflect. There will be no refraction. So here, as this is the incident ray which is more than the critical angle, means the refracted ray has made a 90 degree angle. If we go further than that, then it would reflect back in the same medium. Something like this. So here, as you can see, there is no refraction because the light is not passing from one medium to the other. It's on the same medium. It's just getting reflected. And here, as you can see, it's getting reflected. This is the incident ray, and here it's getting reflected. Such a phenomena is called total internal deflection. So we can tell that this phenomena, that is the total internal reflection, happens when the angle of incidence is more than the critical angle. The critical angle is a certain angle where the refracted ray angle will be 90 degree. Now if the incident ray angle will exceed the critical angle, then it will get reflected. The refracted ray will get there will be no reflection. The ray will be reflected. We can't say refracted then more anymore. We can't say refracted ray. It's a ray, so the light will just get reflected as it's shown in this diagram, and this is total internal reflection. So step by step I've explained like critical first angle. First I've explained refraction, then I've explained critical angle, and then I've explained total internal reflection. Now I need you to all think about this for some time and bring it together and see this video see this videos for some more times. Then you will be able to understand this total internal reflection phenomena. The total internal reflection phenomena happens in a real case where it happens. So if you have seen a mirage, what is a mirage? It's like thinking, okay? It's actually not there, but it's what we think. It mostly happens on desert areas. Now, why this mirage occurs? Why? Because of the phenomena total internal reflection. And for this, I need to make a new video for this. Okay, because why mirages happen is not a simple thing. It not only happens because of total internal reflection. There are many more things that are related to this, but mostly the mirages that we see happens because of total internal reflection. But there are more other points or phenomena happen in mirages that you have to learn. So for this I would make a separate video for that. I hope you learned a lot from this video. I hope you learned about total internal reflection related with the refraction video that I made. So I need you to watch all my videos, and also please subscribe to my channel, and please like this video, and please comment and also share this video to all your friends and families. Now till then, goodbye. Meet in the next video.